Good morning or good afternoon. Today we're going to look at angles, and with the angles we are going to either look at measuring or classifying them or identifying angles. And the first lesson we're going to look at are just some vocab words again in 1.4, and then we're also going to do 1.5 today. And looking at your vocab that you did the first day, a lot of you are very good at giving examples of all the different kinds of angles, so I think these two lessons should be okay for most of us. The first thing, angle. What is an angle? It consists of two different rays with the same endpoint, and I have a picture there for you. Sides of the angle. The sides are the rays, and you can see that right there, and the vertex is the endpoint, and that's what holds the two rays together. The measurement of an angle. Although you can have measures of an angle larger than 180, and later we will have that, but for this chapter you're always going to be looking at an angle between 0 and 180, so if you just want to highlight between 0 and 180, you can do that. Acute angle, and most of you got this right on your vocab, very good. Between 0 and 90. Right angle measures 90 degrees. Obtuse angle is between 90 and 180. And a straight angle, I was a little surprised that more of you didn't get that right on your vocab, but it just measures 180, okay? Or it's just a line. Congruent angles. We heard that word a few times now over the past few days. The same measure, angles with the same measure, and again, the congruent symbol is an equal sign with a tilde or tilde on top. And angle bisector, remember I said we're going to hear that word bisector a lot in geometry. It's going to cut it into two equal parts. We had segment bisector that cut the segment into two equal parts, and now an angle bisector cuts the angle into two congruent parts. We saw when we had a segment bisector, we added tick marks to our picture to show the congruency. With our angles, we are going to add arcs. Okay? Now, it gets a little confusing for people that don't have geometry before when they see these arcs, but we do need to stagger the arcs. The reason we stagger the arcs like we do, and we don't want to draw one continuous arc, is because the mistake here would be if you draw one continuous arc, the reader would think that you're talking about the large arc, not two congruent arcs. So you want to make sure that you stagger the arcs. Now, if you don't have a geometry course or some other course that talks about this, it might be a little misleading that this arc looks larger, so you might think, well, that means that the angle is larger. No, it's showing congruency. So the arcs don't show how large the angle is, it's showing congruency. Okay. The next one is a postulate. Remember, postulates are common sense. And the first postulate talks about the measurement. Here's a good time to introduce how do we look at the notation for an angle. And an angle symbol is right here that I have circled in green, and it has a flat bottom. Sometimes when I type out a worksheet or notes that I have, if I feel a little bit on the lazy side and I don't want to quite take the time to go find the angle symbol, I'll cheat a little bit and use the less than symbol. The less than symbol, though, does not have a flat bottom. That's incorrect, okay? So this is the lazy way, and that's incorrect. An angle symbol actually has a flat bottom, where a less than symbol does not. So when you're writing it out, make sure you use a flat bottom. Once in a while, when I am typing, I will cheat a little bit because it takes a little while to always go find the symbol for angle, and I'll use the less than symbol. Okay, and then you'll see that we can either use one letter or three letters depending on the situation, okay? And I'll get into that later. But here we talk about the measurement of angle AOB, and if you just follow along, AOB would be referring to this angle is the absolute value between the real numbers for the two rays. Okay, and it's again talking about the measurement of that angle. Now on the next postulate, it's the angle addition postulate. we saw already in this chapter the segment addition postulate, and that's basically the same thing. The angle addition postulate says if you take two smaller angles, and they really should have staggered this to show you that they were talking about the two individual ones. Oh, I guess they did show that they were talking about the big one there, because off on the side here it says RST, which is the big one. But it says the measurement of the two smaller angles, going down here to the bottom, RSP plus PST, follow it along, PST, you go in the order that they give you, equals the large angle, RST, and that's the large angle. So two smaller angles equal a big angle. And again, postulates, common sense. Okay. Okay, here is a sheet, and we're going to talk about ways to name angles. And this is where I told you sometimes you can use 3 letters, sometimes you only have to use 1. When do you only have to use 1 letter? If there's only 2 rays coming out of it. So the picture on the left, I could simply call it angle A, where the picture on the right, I cannot call it angle D. I can't call it angle D because the reader would not know, is she talking to about angle EDF, FDG, or the larger angle EDG? Okay, so this picture, because there's only 2 rays coming out of A, I could refer to it as angle A because there's only 2 rays coming out of it. This one I could not refer to it as angle D because there's more than 2 rays coming from the vertex. Okay, now go ahead, and I'm not sure if you'll be able to switch these around, but maybe if you can't switch them around physically, which I don't think you'll be able to do, just write beneath them small, medium, or large. Okay, if you're not done yet, hit pause and then just simply hit play again. And angle EDF, the green one, is where you should have the small. FDG is the medium, and EDG is the large. So I had the 2 switched around, the green and the red. Okay. And again, the middle letter needs to always be the vertex, and the other 2 letters, F and E, could have been switched around, and the other 2 letters on the medium one could be GDF or FDG. Doesn't matter on the other 2. Okay, but the vertex always has to be in the middle. All right, measuring angles. Go ahead and grab a protractor and see if you can make it so that you get at least close to 48 degrees for this. And if you get close to 48, great, then we can assume that you pretty much know how to use a protractor. If you don't get to 48, then during work time, please ask a table partner to help you refresh your memory on how to use a protractor. Or maybe if there's a few of you that have never used a protractor, please ask for help so that we make sure everybody in geometry class have at least used a protractor a few times. Okay. Now the next one, we'll just try it one more time. Go ahead and hit the pause button. Oops, I gave you the answer there for one of them. Go ahead and hit the pause button and fill in the answers to the measurement of EDG, FDG, and then see if you can write down the notation of what would you write down for the third angle. What's the third angle in the picture and its measurement? Okay, and hit the pause button, do it, and then hit the play button after you've done so. And you can either do this again in Notability, or if it's not working for you to do it in Notability on your screen, come up and I have some hard copies printed out on my desk. Okay, check your answers. The measurement of EDG, which is the larger angle, is 85 degrees approximately. FDG, which is the medium-sized angle, and I'll put an arc in there to represent it with the blue marker, is approximately 69 degrees. To find the third angle, you could either subtract them using the same idea that we did the other day with the segments, or you could go ahead and try and measure that smaller angle, which I'll mark here in pink, or again, use the properties that we did the other day with the postulates. The big one minus the medium one will give you the small one. And when you label it, you should label it either EDF or FDE. Just make sure you have D in the middle and F and E surrounding it. And you should have got approximately 16. Okay, next. Some problems you will not be using a protractor, and I'd like you to put the protractor away. No more protractor today. And now you want to use the same logic that we did earlier in the chapter. If it gives you this information, the measurement of angle EDG equals 88 degrees, find X and the measurement of EDF and FDG, please. Pause it. Fill in your work, and again, you can either try to write on the iPad with Notability, or if it's not working for you, just come up and get a hard copy, please. Pause. Okay, now you should have had your work worked out after you've hit play now to check your answer. Okay, so using the same logic that we did before, 2 parts equal a whole, so you should put your x terms together and you'd have 5x. Put your plane numbers together, -2 plus 5 equals 3 equals the total of 88. One thing also I would have done is right away when I started, I would have marked the whole arc on the side of my paper and said that equals 88, just so I kind of gave myself a little reference there. Okay, and I'm using my mouse, so sorry it's a little messy sometimes. Okay, so then solving it, again, subtract 3 from both sides and you get 5x equals 85. Divide both sides by 5 or multiply by 1/5 and you get x equals 17. And remember, always read the question. It says find x, so that's one part of it, but it also says find the measure of the 2 angles. Here's a good time to mention, and you'll just get better at this as we go, but when you're talking about the measurement of an angle, you're going to be putting the little m in front of it, and then say the 3 letters, and then the actual measurement of it. When you're actually referring to just an angle, you'll leave off that little m. Okay, so when you're writing down the measurement of an angle, you'll put a little m on there. When you're actually just referring to the angle, you won't have the little m in front of the symbol. Okay, and again, this time I did cheat a little when I used the less than symbol, but remember, it should always have a flat bottom when we actually write it out. Okay, oops, why am I using that pink? That pink has an arrow on it. Okay, next. Go ahead and try this problem. Think about what does this symbol mean in the corner that would allow us to solve it. Hit the pause button and then check your answer again, please. Okay, hopefully you realize that that symbol meant 90 degrees, and if it was me, I would have probably put a little 90 in the corner there to remind myself. And then again, adding like terms and setting it equal to 90. So we get 3x plus 3 equals 90. Subtract 3 from both sides, we get 3x equals 87. Divide both sides by 3 or multiply by 1/3 and we get x equals 29. And then to finish off the problem, it says find x and the measure of each angle. So go ahead and put the 29 back in. 29 plus 1 equals 30. 2 times 29 plus 2. 2 times 29 is 58 plus 2 is 60. And then it's always a good idea to look back at the picture and make sure it really did equal what we were supposed to. 30 plus 60 is 90. So that's what we were supposed to get at the beginning, so we give ourselves a little happy day. Probably should have done that with the last one too. If we went back and we said 49 plus 39 equals 88, happy day. Okay. Review. How can we show sides are the same length? We show sides or segments are the same length with ticks. How do we show angles are equal in measure? With arcs. And again, if they were hooked together, make sure that you stagger your arcs. Here we see for the first time 2 arcs. What do you think that means? It means we have 2 different sets that are congruent. So here it says identify all pairs of congruent angles. We have 2 pairs this time that are congruent. We're going to say angle L is congruent. Let's see if I can find the congruent symbol quickly. Yes, I can. So we're going to say congruent to angle M. And again, I'm cheating a little bit with using the less than symbol, but remember, if you were writing this out, use the real one. And then we're going to say angle P is congruent to angle N. And when I make mistakes, realize that this software doesn't let you go back and just rewind a little bit. You have to completely start over. So sorry about when I make mistakes. I just have to kind of go with it. And lastly, is the measurement of angle, what is the measurement of angle N? Well, it told us if P was 120, and if they're congruent, then angle N has to also equal 120. And now because I gave it a number and not just talked about the angle, then I'm going to put the little m in front of it. So the measurement of angle N equals 120. Next, in the diagram at the right, ray WY bisects. As soon as I hear that, I'd arc it up if it was not already done so, but it was for me. And the measurement of x WY equals 29, so I'm going to put a little 29 in there. Find the measurement of XWZ. XWZ is the large one. So if these are alike, I could put a 29 in this one also. So that means the big one is 29 plus 29, or 29 times 2, which is 58. Go ahead and try this one. Read the question. Pause it. Good. 156. Same idea as last time. Okay, 1.5. When you're looking at 1.5, we're going to look at different vocab for angle pairs. Complementary angles are two angles whose sum is 90 degrees. Supplementary angles are two angles whose sum is 180. If it's written out, one way that you can kind of remember between the two is complementary has 1p, so it's the smaller of the two numbers, 90 versus 180. Supplementary has 2p's, and it's the larger of the two numbers. Adjacent angles are angles that share a common vertex and side, or the way I like to think of it is adjacent, they're hooked together. So they're hooked together and they have to share a side and a vertex. Linear pair, they're two adjacent angles again, so they share a side and a vertex, but they also form a line. Okay? So adjacent angles, they don't necessarily form a linear pair because they don't form a line. This could be 60 and this could be 20, so it only equals 80 or something, where this will always equal 180 because it always forms a straight line. And if you look at the word inside linear pair, again, it gives it away. Linear has the word line right in it. Vertical angles, angles where their sides form two pairs of opposite rays. And when you draw out two lines, it's just two angles directly across from each other. So here I have angles 1 and 2 would be considered vertical angles. There's another pair whenever you have vertical angles, and those would be like 3 and 4 here would also be considered vertical angles. Okay. Oops. I forgot to cover up those answers. Okay, so name a pair of complementary, supplementary, and adjacent angles, please. And when you do this, you're going to write down a 3-letter combo for each one, a 3-letter combination for each one. Okay, hopefully you got these. Complementary angles add up to 90. So ABD was 52 degrees. Or again, remember you can have the 3 letters switched around. Just make sure B is in the middle. DBA would also be acceptable. And BDC was 38. And again, 52 and 38 equals 90. And again, you could also have CDB here. Just make sure D is in the middle. Supplementary adds up to 180. So you need the 52 angle and the 128 angle. Adjacent means they're hooked together, so it doesn't matter on their measurement at all. They just need to share a vertex and a ray. So in this case, they shared ray DB and they shared vertex D. And again, you could switch these letters around. Just make sure you have D in the middle. And again, they can add up to whatever. So in this case, it was a 38 and a 128, which added up to 166. So it really had no bearing on it. Okay, next, looking at the pictures, you're going to have two pairs of linear pairs and only one pair of vertical angles in the picture. Go ahead and name them. This time you're just going to name them by numbers. So you're going to have two pairs of linear angles and one pair of vertical angles. Write them down, please. Okay, make sure you hit the pause and then check your answer. Don't just keep going. All right, so now that you've checked your answers, linear pairs would be 1 and 2, form a line, and 2 and 3. Why not 3 and 4? Because again, they don't form 180 degrees. If you're looking at it in approximately, maybe you'd say 90 and 45. So again, 90 and 45 wouldn't give you 180. And if you're thinking, well, why couldn't you write down 1, 4, and 5? Because that forms a line. It has to be a pair. Pair means 2. Vertical angles would only be 1 and 3. And that gets a little tricky until you get used to looking for vertical angles. But again, 2 is not directly across from just one particular angle. So if you think, well, 2 is across from 5, well, if you extend this ray out, what is 5 across from? It's across from only part of 2. That's why 2 and 5 aren't vertical angles. Okay? Same thing with 4. 4 is only apart from part of 2, not all of 2. So that's why they're not vertical angles. 1 and 3, if you cross their lines, they are directly across from each other and only their lines. Okay? 1 and 3 are the only pair of vertical angles here. This isn't working for some reason right now, but maybe during lunch this little game that I made for angles works, and then you can come in and earn some bonus points if you'd like, if I can get it to work. Okay, next, the last thing I'd like you to do, or almost the last thing, I think we're almost on the last slide. Actually, it is the last slide. I'd like you to draw two angles that form a linear pair. And again, remember what the word linear means. Think of the word inside of it. Label one of the measures X. Label one of the angles X. I think I said label one of the measures. And then label the other angle 4 times the measure of the other. So how would you label that? Okay, so if you did this on your paper, draw a linear pair, 2 angles hooked together by a common vertex and they share a side. And now if you label one of them X and the other one 4X, now how are you going to go about solving that? Just like we did before, using common sense, a postulate. A linear pair equals 180 because it lies on a straight line. So we're going to say 5x, 1x plus 4x, 1 elephant plus 4 elephants equals 5 elephants equals 180. Divide both sides by 5. 5 will go into 18 3 times. And you have 30 left over. 5 will go into 36 times. So x equals 36. So it says find the measure of each angle. The smaller angle is going to be 36. The larger angle is going to be 36 times 4. 24, 12, 144. And then always double check your work. 144 plus 36. Does that give you 180? Yes. Happy day. Okay, that's it for today. Hopefully you have enough time to do your homework. And there's 2 worksheets today. Come on, grab those off the front desk here. And have a good day.